So B2, prime factorization. Which of the following numbers are prime?
Prime are even numbers, right?
Not necessarily. Actually, by definition, no even numbers are prime. So they'll always be odd. But that doesn't mean that all odd numbers are prime, okay? A prime number means that the number can only be divided by itself and 1, and then we would still only be left with whole values, okay? So what this means is that I need to split this up into two numbers that multiply together to give me this number that I have. Something like, now this one is not prime, but I'm going to look at 6, okay? Just as an example. So what two numbers multiply together to give me 6?
6. No, 3
Yeah.
and 2.
Yeah, both of those work, right? So I heard 6 and 1, right? 6 times 1 is 6. Now if that was all I could find on that, then that would be considered prime. But like you said, we can make 2 and 3 also equals 6 right there. Because we have more than just that one set, 1 and itself, and then we have the 2 and the 3, that makes this one not prime. So let's look at a prime number, such as 7. So what two numbers multiply together to give me 7? Now this may take some time to think about, which is okay. But yeah, 1 and 7 would work. 1 times 7 is 7, that's good. But what other two numbers? Now, again, we don't want decimals for this, okay? Not that we've gone over decimals anyways, but for prime numbers, we're never looking for decimals. Only whole values, like we see here. Well, there are no other numbers. You could think as long as you want. And there's no numbers that multiply together to give me 7 other than 1 and 7. So that is what makes this one prime. So yeah, more formally, I'm just going to repeat that for the video. The only two numbers that multiply together to give me that number are 1 and itself. If I could find any other two numbers that multiply together to give me that number, then it is automatically not prime. And that's why even numbers are never prime, because they're always divisible by 2. 2 multiplied by something will always give me an even number. Yep. So prime numbers automatically have to be odd. So let's take a look at this list. Which of the following numbers are prime? Circle all that are prime.
Times by anything else by itself.
Right.
So it is a prime.
So it is a prime number, right? So 2, as it turns out, is the only even number that is considered prime. Now what about 44? So we know 1 times 44 is 44. This will work for any number, 1 times itself. But are there any other two numbers that you can think of that multiply together?
4 and 11.
4 and 11. Now just that we have that shows that this one is not prime.
31 times.
Now are there other numbers that multiply together to give us 44? Yes, there is. But we're not concerned with those because we already figured out one other one, okay? So we're not asking for all the sets. Just as soon as we get something other than 1 and 44, then we're pretty much done with that stuff. All right, what about 31?
Times 31. 5 times.
So yeah, automatic. We got 1 and 31 always.
Yeah, that's a prime number. I can't think of no other numbers.
Yeah. Right? So 2 times something, it's going to have to be a decimal. 3 times something, again a decimal. 4 won't do it. 5, 6, 7, 8. It's not divisible by any of those. So we know that we can't multiply it by anything other than 1. So yeah, this one is prime. Now on that one, I kind of mentioned division on that, right? So if we can divide these numbers by anything other than 1 to get something that's a whole value, then it would be not prime. Now 29, of course, just like the other ones, 1 times 29 That will always work. No, it's a 9. But is 29 divisible by anything else? It's not divisible by 2, because it's odd. It's not divisible by 3, because the closest one will be 30 or 27. 4 doesn't work, because you can get to 28, but not 29. 5 doesn't work, because you can get to 30. 6 doesn't work, because again, 30. And 7 gets you to 28. And we could go all the way up on that, but still. We couldn't find anything on that, so that would be considered prime as well. Now, do you see how it takes some thought on this, right? And we're running through the numbers. Some of you may have noticed, as soon as I got to 6 and 5, so it was just reversed on that. 6 times 5 is 30. 5 times 6 is 30, so automatically all the other numbers won't work for us, okay? So let's address this once again, okay? So if it's even, automatically it's divisible by 2, right? Meaning we can find something multiplied by 2, which would give us 72, which in this case would be 36, okay? So that makes this one automatically not prime. So if a number ends in an even number, 2, 4, 6, or 8, even 0, then it's automatically not prime. Okay. I didn't see any on here, but I think we'll see some on the next section. And there's kind of a trick to see if something's divisible by 3. But again, I don't see it on 89 either. 72 would work for that, but again, let's focus on that one being even instead. So 89, let's see on 89. So yeah, let's look at this list, okay? 1 times 89 works, because that's 89. Because 1 times anything is going to give you the thing back. It's not divisible by 2, because 2 times, I don't know, I guess that'd be 44, would maybe give us 88. So that doesn't work. Right. 2 times 45 would give us 90 as well, so that doesn't work either. 3 times, 30, that would give us 90, which is close, but it's not exactly on the spot there. 4 times 22 would give us 88. Again, it's close, but it's not quite there, right? What about 5? 5 times, what would that be?
35.
Gonna look at 18 for now. 5 times 18 would give us 90. Again, it's very close, but it's not quite there.
So that's a prime number.
Let's keep looking, just because we're enjoying this so much. So 6 times 15 would give us 90. Again, it's close, it's just not there. And what about 7? 7 times 13 would be 91. Again, that's very close. Well, what about 8? 8 times 11 would be 88. Again, that's very close. 9 times 10 is 90. Now, something you may have noticed about those numbers, now again, 9 times 10 doesn't work. See how we got closer and closer together? 1 and 89, farthest apart. 2 and 44 get closer. 3 and 30, 4 and 22, 5 and 18, 6, 15, 7, 13, 8 and 11, and then 9 and 10 are 1 away from each other. Since that's the case, we couldn't go any further, right? We could go back to 10, but again, we're going to go 10 and 9, 11 and 8, 13 and 7. I mean, we could try 12, but 12 didn't really work with any of these other ones either, so looks like it's not divisible by 12. There we go. Which of the following numbers are composite? Select all that are composite. So a composite number really is just one that is not prime. That's it. Okay.
Okay.
So if it's, so we hadn't gone over that yet, but the ones that we wrote not prime on that last problem, we could easily just write composite on those. All right, but we can look at the ones that we do have that are similar. So 2, this one is not composite because it's prime. You see that right there. 44 was not prime, so this one would be composite. We don't see 41, 27. I don't see 59, 68, 49. I got 89 though. That one was prime. So this one is not a composite. Looks like the other ones are different. What about 41?
I want to say that one is not composite.
Yeah. Since this one is prime, yeah, it would be not composite. I'm just going to put prime on that because it's shorter than not composite.
Yeah.
And then cross it out. Okay.
It says
The crossed out ones, even if they're circled, are primes. 27. So this one's a divisible by 3 one. And how do we know that? So first of all, it's not divisible by 2 because it's not even. But one way to know if a number is divisible by 3 is to add the digits. 2 plus 7, that's 9. Is 9 divisible by 3?
yes.
Yeah, well, 9's a lot easier to look at. So this one is divisible by 3. So what that means is 3 times something will give us 27. That'd be 3 times 9 is 27. So yeah, this one is a composite. All right, now that was just divisibility by 3. 59, I mean, it may look like it's divisible by 3 because it ends in 9, right? But if we add these two numbers, we'd get 14. So automatically, we can see 14 is not divisible by 3. If we weren't sure that 14 was divisible by 3, we could add those and get 5. 5 is not divisible by 3. So that just tells us that 59 is not divisible by 3. It's not even, so it's not divisible by 2 either. So yeah. Yeah, this one is prime. So it is not a composite. 68?
It's composite.
Yeah. This one's even because it ends in the 8, so automatically it is composite. 49?
Right. Oh no.
So this one's a little bit different, but this one, yeah, so it's not divisible by 1, 2, I mean it is divisible by 1, but 2, 3, 4, 5 doesn't work, 6 doesn't work, but 7 will. This one splits up into 7 times 7, which would be 49, making this one composite. 81, now some of you know that this is divisible by 9, but again, if we add those two numbers together, we get 9, which we know is divisible by 3, so this automatically is composite. Specifically, this would be 3 times 27. Not that you guys care, but that just shows what it's. This is what I mean by divisible by 3, okay? 3 times something is that number.
Composite.
Yeah.
Because it's a even number.
That's correct. This one is even, so it is composite. Actually, 3, so if anything is divisible by 2, the number in the ones position will be even. If it's odd, it's automatically not divisible by 2.
Oh, so only one of those are divisible by 2.
Well, let's look. So this first one, right? This one ends with a 7. That is odd. 7 is odd. So this number is not divisible by 2. Automatic. This next number has a 5 in the ones position, which is odd. So it is not divisible by 2. The next number has a 6, which is even in the ones position. So it is divisible by 2.
Oh, so the last one.
And then, yep, that last one, 4 is even in the ones position. So it also is divisible by 2 because 4 is even. Now, on the other hand, this number 4, which of the following numbers are divisible by 5? 5, if something is divisible by 5, then in the ones position you will either see a 0 or a 5. That's it. Okay. Now 0 is even, so it could also be divisible by 2, but let me take that back. 0 itself is not even or odd, but in the ones position with other numbers it is. Right, like 50 would be considered even, but we're looking for divisibility by 5. Well, 50 has a 0 in the ones position, so it is divisible by 5.
Because 5 times 10 is 50.
There you go. 70 has a 0 in the ones position, so it also is divisible by 5.
The other two are not.
Yeah, very good. 62 has a 2 in the ones position, so it is not. 74 has a 4 in the ones position, which is not 0 or 5, so it is not divisible by 5. There you go. Now, which of the following are factors of 112? Meaning, what numbers in this list could be multiplied by something else to give us 112? So to do this, what we can do is we can divide 112 by these numbers and see if we get a whole value. If there's anything remaining, then it is not a factor of 112, because we couldn't multiply the number by something, some whole value to get 112. So another way to think about this is 112. Is it divisible by 2? Well, we just went over rules for divisibility by 2. And if the number in the ones position is even, then it is divisible by 2. So automatically 2 is. So you could divide it like we're going to do with 7 here, but it may not be necessary. Let's look at 7 then. So I am going to take 112 and divide it by 7 to see if I get a whole value with no remaining values there. So 7 will go into 11 once. That's a 7. Subtract, I got 4 remaining, 42. 7 will go into 42 6 times. 6 times 7 is 42. And I do have 0 remaining, which means that 7 is a factor of 112. Particularly 7 times 16 would give us 112. So what about 3? Is this divisible by 3? 112.
I say yes.
Let's find out.
Okay.
So divide this by 3. How many times is 3 going to 1? 0. What about 11? 3 times. 3 times 3 is 9. Subtracting, I got 2. I'll drop this 2.
Oh, it's 9.
3 goes into 22 7 times. So that's 21. And yeah, I got the 1 remaining, which means that 3 does not go into 112. Now, some of you saw this as well, right? Remember the rule for divisibility by 3?
It's got to be odd.
Not always. But if we add the values of just the numbers and we get another value that's divisible by 3, then it is divisible by 3. Well, this is 4. And 4 is not divisible by 3, which confirms that 3 is not a factor of 112. All right, what about 9? So again, we could take 112 and divide it by 9. 9 goes into 11 once. 1 times 9 is 9. Subtract. I got 22. 9 will go into 22 twice, but not evenly. So I got this 4 remaining, so 9 is not a factor of 112. Very good. Yeah, so 112, the ones position is a 2, which is not 0 or 5, so automatically it is not divisible, or that 5 is not a factor of 112.
What is that?
Or factorization. Prime factorization specifically. So factorization, or factoring, that would sound better. Factoring these numbers is just splitting these numbers up until all we have are prime numbers remaining. Now, usually the prime numbers that we'll see are numbers like 2, 3, 5. Maybe sometimes you'll see a 7. maybe even 11 or 13, but we don't usually see those very often. Now, if they're even, automatically we know that these can be divided by 2. So what I usually do is I use what is called a factor tree, which means that I'm going to branch this 10 out into 2 other numbers that multiply together to give me 10. So those are called factors, the numbers that multiply together to give us 10. Now, sometimes we may get different numbers because there's many factors of certain numbers. 10, though, the only 2 numbers I can think of are 2 and 5. 2 is prime, 5 is prime. So the prime factorization is 2 times 5. Now, if there were more prime numbers in this list, then I would have listed those out with the multiplication. Okay, but in this case, there was only these 2 numbers, which is fine. So we kind of have to know what some of the lower prime numbers are, because we're not, as far as I remember, we don't throw any big prime numbers at you, but sometimes they will. So 20, let's split this up into 2 numbers. Now, some people even branch this out into 3 because they know 3 numbers, but I like to stick with just 2. So what 2 numbers multiply together to give us 20?
2 and 10.
2 and 10. So that's going to be these branches. Now, some of you may have even said 4 and 5, right? Which would work. But for our example, we're going to use 2 and 10. 2 is prime. 20 is not, which means that I can split it up even further. That was supposed to be 10. I'm sorry. 10. Well, we just did 10. So what 2 numbers multiply together to give us 10? 2 and 5. So there's those. So the final prime factorization would be 2 times 2 times 5. And if we did multiply these together, we would get 20.
Times 5 is 20.
That's correct, yeah. Now, keep in mind, I'm not completely sure how the homework wants this, but the order of these I don't care about. Some people want to see these from lower numbers to bigger numbers, and it wouldn't matter to me, again, because the arrangement is going to give us the same value. I could do 2 times 5 times 2 and get the same number, okay? All right, so let's split up 96. So what 2 numbers multiply together to give us 96? Now,
3 and 2.
that would be 6, right?
Oh.
Now on this one, though, there's a couple that we should look at, all right? First of all, 6 in the ones position is even, so I know it can be divided by 2, all right? On the other hand, if I took 9 and added 6, I'd get 15, so it's also divisible by 3, which means we got some choices right here, okay? It's also divisible by 4, but we'll find that later. And if we can just stick with 2 and 3, then we should be good. So which one do you want, 2 or 3?
3.
3? All right, so I got 3, which is prime, but I got to figure out this other number, right? It'll be kind of big. To do that, I'm just going to take 96 and divide it by 3. Well, 3 goes into 9 3 times. That'll be 9. Subtract 0. 3 goes into 6 twice, and then I got 0 remaining on that. So the answer, that's a 0, is 3 times 32. Now I can look at 32, which ends with a 2. So I know automatically that that is a composite number, so I can split that up as well. Now it's even, so again I can use 2. And then 2 times what is 32? Again, I would divide. 32 divided by 2, 1. Just for the sake of time, I'm going to shorten that. 16. 16 also is even, so I can split that up into 2. 2 times 8 is 16. 8 also is even, so I'm going to split that up. 2 and 4. And then 4 splits up into 2 and 2. So I'm circling all of the prime numbers once I get them, okay? Or once I've simplified that as far as I can go. So the final answer on this one is all of those numbers multiplied together. So I got 3 times 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s. So yeah, you could have used different numbers on this. Like I think 4 and 24 work. But again, it's all a matter of preference or what numbers you know to divide by, okay? 3 and 32 isn't a common multiplication problem, so knowing that 3 times 32 is 96 may not be as normal for us. But again, we can still use long division to see what that other number is, if we need to. All right, so on 216, did you guys split it up once?
Yeah, I got 3 times 6 times 2, but that's not right.
I did 72 and 9.
72
times 9.
So yeah, we can see that this one is divisible by 3 because when we add these numbers together we get 9, which just, it doesn't mean that 9 is necessarily a factor of this. It just means that 3 is, though. So we do have that 3 there. And now we can split these up. 3 is prime, though, so I'm going to circle that. So we should split up 72. Now this is even, but we don't have to use 2, though, right? So this one would split up then into 12. Let's use 12 and 6, neither of which are prime. But we can split both of these up. 12 can split up into
6.
Let's use 6 and 2. See, then we got 6 as well. 6 splits up into
2 and 3.
2 and 3. So those are both prime. So this 6 also splits up into 2 and 3, which means our prime factorization, again, I don't really care about the order, but 2 times 3 times 2 times 2 times 3 times 3. Now, if you did want to rearrange it, that's fine. 2 times 2 times 2 times 3 times 3 times 3.
So there's
All right, so this would be good enough for me, but as it turns out, the homework does want this to use exponents. So what that means is that, see, I've got these 3 2s.
oh, so it would be 2 squared or 2
Cube, right?
2 cubed, yeah, right there.
and then 3.
Yeah, then we got the 3s as well. And we got 3 of those. So that also would be cubed. So this actually ends up being our final answer right here.
Oh, so there was a way to.
All right, let's split this one up. Now the nice thing about 15 right here, 800, is it ends with 0.
So no, it's 5,
So 5 or,
15.
2.
I don't know about 15, 2 or 10. Okay. If it ends with a 0 in the ones position, we can at least divide it by 10. Okay. So if I split this up, I can split this up into 10. And then the other number I would multiply that by would just be the same number, but without one of the zeros. Okay. So 80 times 10 would give us
800.
800.
So then we got to break that down.
Yep. Now let's continue breaking. Let's break down 10 into. We've done that one already, 2 and 5. So 80 splits up. 80 also ends in a 10, so I can make that 10 and 8. And then I can split 10 up again into 2 and 5. And then 8 we can split up into 2 and 4. Then 4 splits up into 2 and 2. So I've simplified this as far as I can go, or factored it. So let's go ahead and list those numbers. Now, I do want these in order so I can use the exponents though. So I've got 1, 2, 3, 4 2's, 5 2's. 1, 2, 3, 4, 5 2's. And then I also had the 5's, the 2 5's, times 5 times 5. So to write this in exponential form, I got 2's, and I've got 5 of them. 2 to the power of 5 times these 2 5's, which would be 5 to the power of 2. That'll do it. Like 11, right? We would want to change this one to 3 times 2 to the power of 1, 2, 3, 4, 5. Yeah, so that would be the actual answer for 11. This one would have been 2 to the power of 2 times 5. All right, 10, 58. If I add those, I get 13, which is not divisible by 3, so I know that. Yeah, this one, we'll just look at the 8 there, okay? So 8 is even, so that means I can divide this by 2, which would give us what? Well, then I've got to do 58 divided by 2. So I got 2, subtract the 4, 18, and 9. 2 and 29. 29 is prime. Now we could have tried to split up 29, right? 9 and 2, again, don't add up to anything that's divisible by 3. It's not divisible by 4, 5, 6, 7, 8, 9, 10, 11.
2 times 29 is 58.
That's correct. Yeah. So that's it. This one just ends up being 2 times 29. All right, 17. This one may just be kind of difficult to determine what to divide it by. Because it's not even, so it's not divisible by 2. It doesn't end in a 5 or a 0, so it's not divisible by 5 or 10. So as it turns out, we'll want to add these together to see if it's divisible by 3. Yeah, right? If we add these numbers together, we get 9. So that means that it's divisible by 3 right off the bat there. Okay? Now we don't really need this stuff. But again, that's just to determine that it is divisible by 3. So, to figure out what that other number is, we'll have to divide. 153 by 3 goes into 15 5 times. Subtract 15.
51.
51. There it is.
So that's a prime number.
Well, let's check. So this one is a little different as well, right? So if I took 5 and added 1, what would I get?
6.
6. So as it turns out, 51 also is divisible by 3. So I got to do 51 divided by 3 as well. So that's 1, 3. I got a 21 there. 17. And 17, 1 plus 7 is 8, so that's not divisible by 3. And it's not divisible by 2, 5, 10, 7, any of those other numbers. It is prime. So I ended up with 3 times 3 times 17, which again would be written as 3 squared times the 17.